Hi guys, I will be starting with C++ 11 new features part 6. So I'll be covering these features which I have mentioned here guys, that are the variable size as well as lambda functions. So guys, in the introduction part which I have covered in the earlier session for the C++ 11 new features, I've already mentioned I've divided the whole session into different parts from part 1 to part 8, and I've covered different features of C++11 actually, so that we will be covering whole features till part 8. It will be convenient for your purpose guys. So let's see actually these two features in this part 6. Also guys, I have made a list actually of the summary of the features which I have covered in the previous part. So if you have not gone through it, so guys please go through it. So these are the features which I have covered in the previous part. I have covered auto, I have covered initializer list, uniform initialization, null pointers, static assert, overlapping and delegating constructors, converting constructors and explicit, override and final, default and delete, const, expr and symbolic constant. So guys, let's see the new features in this part 6, that is variable size, and then we'll be seeing lambda function guys one by one. So guys, what is this variable size? So guys, in addition to C++, what all data types are available, C++11 is providing you few more data types. So I have listed actually different data types actually. So some of the data types are common to both C++ and C++11, and some of them are unique only to C++11, which you cannot use for C++. So guys, also the data types is dependent actually. This is just a note down, dependent on the compiler as well as computer architecture. So even there is size of the data type is defined, but depending upon the compiler and computer architecture, it may vary. So let's see guys the whole list of different data types. So guys, these are the data types. So the guys I have mentioned actually, which is just unique to C++11, I have mentioned it explicitly. Let's see. So guys, this boolean is 1 byte. So this is common to both C++ as well as C++11. You know guys, character 1 byte common to both, char underscore t common to both. So guys, char 16 underscore t, char 32 underscore t. So these things guys are mentioned here, C++11 specific to C++11. So since you know that char underscore t is of 1 byte common to both, that is C++ and C++11, in case of C++11, it is also providing you with this new data type, that is char 16 as char 32. So you can use any of them depending upon your requirement. If you want character to be 16-bit, if you want 32-bit, you can use C++11 actually if you want these features. So guys, these are again common actually to both C++ and C++11, that is for integer short 2 bytes, integer 2 bytes, long 4 bytes. So guys, for long actually, that is 8 bytes actually, that is you can use in C++ and C++11 also. Guys, floating point 4 bytes, double 8 bytes, long double 8 bytes. So guys, these are the list of different data types actually, and specific to C++11 I mentioned here itself what all data types is used guys. So guys, also a note point. So this long is specific, can be used actually in C++11. So you know that in C++, if we want long, it will be of 4 bytes, guys. If we want float, it will be 4 bytes. If you want double, it will be 8 bytes. If you want, if it is a long double, it is 8 bytes. In case of C++11, for 8 bytes, we can use long guys. So guys, let's see a note point. So actual size of the variable may be different on your machine. As I told you, it is dependent on the compiler and computer architecture. In order to determine the size of data types on a particular machine, C++ will provide an operator named size of. So you know guys what is size of. By the size of, compiler will calculate the size of different data types. If you call this function and pass the different data types, the compiler will mention you what all size the different data types have. So guys, this is a simple snippet of the code which will just to get a clarity actually to print the size of different data types, I have written this program. It's a simple program. So it's just a display message displaying the size of different data types. So here I have since you know that entry of the program guys starts from the main function actually. Therefore, when you compile your program, the execution of program starts from main function. So what all instructions you mention in this main function will be executed line by line. So this is a display message displaying one by one the size of different data types. So size of bool, size of char, size of wchar underscore t, this char of size of char 16 underscore t, char of size of char 32 underscore t, size of short, size of end. So guys, in this manner I just simply displayed different sizes, and here is the output which you know as I told you, and this will since these things are supported in case of C++11, you can use this char 16 underscore t, you can use char 32 underscore t, you can call the size of function and pass this different data types, and you will get these outputs, and this is for both common to both C++ and C++11. For long it is 8 bytes for C++11, and rest of them are common to C++ and C++11. So guys, this is a display message. So so we are done with this this feature actually, wherein we have seen the size. Let's come to another feature which C++11 provides, and that is Lambda Functions, guys. What is this Lambda function? Let's see. So guys, C++ provides the ability to create an anonymous function called Lambda Function. Why anonymous function? Why it is saying in this manner, guys? Because you don't require to write the name of the function. Therefore, it is called as anonymous function. Without mentioning the name of the function, you can create a function, and that is the reason it's called as an anonymous function. So it allows a function to be defined at a point where it's needed in other expressions. So in the expression itself, instead of calling the function, you can simply write the implementation of the function with also the input argument and with also the return type in the block. Let's see actually how to achieve it. Instead of calling the function at the place where you require to call the function, you can simply dump the whole implementation of the function there itself. Instead of writing a separate function and calling it, you can dig the same code actually implementation at the same place. So this will also avoid the overhead to go to the function and come back to the function. So guys, I will be showing you how to achieve it. So this is just an explanation. So it's a function that we can write inline. So it's simply like an inline function in our code in order to pass to another function. So guys, I have written the snippet of the code. Let's see actually how to achieve this Lambda function, to create a Lambda function. So guys, this is the program which you are including different header file, then you are mentioning the namespace std in C++11, guys. So guys, this is the main function. You know, the start of the program starts from this main function. So you have declared the included header file for vector, and you can call this vector actually. So you can write this declaration. You are creating a vector actually of size 10. And then guys, you are calling this for each function. You are passing 3 arguments in it. So this is a regular simple way in C++. Then we will see how to achieve in C++11. So this is the simple way how you can use through C++, and then how we can achieve through C++11 we will be seeing. So in C++, this is a for underscore each function is called, and 3 arguments are passed. So we are passing vector begin, vector end, and this print function. So what we want actually, so since guys we want actually to iterate through vector actually from start to end and to go through this function, that is print. So guys, in this case since it's a for loop actually, again and again this print function will be called, and till begin to end vector iterations this print function will be called. So one by one this print function will be called, and simply it will be printing the value of the vector actually, vector elements one by one actually, since it's a for loop, guys. So this is in case of C++. Again, in C++ we are calling the same for each function. We are passing 3 arguments, that is vector begin, vector end, and assign. So again this assign is a function. So again till start to end actually iteration of the vector elements, this function will be called assign actually, since it's a for each. So here we have written static and n is equal to 1. You know guys, whenever we are making any variable static actually, so it will resume actually, it will initialize this value 1 actually. So even if the control comes out of this function, still it will resume whatever the value was updated in this function earlier. So if this value later gets updated to 2, 3, and even if the control comes out of this function and again comes in this function, still the value which was there earlier, that will exist actually. It will not, the value will not go actually, because you have made the variable static. So if 1 is modified to 2 or 3 actually, and if control comes out after that and comes again to this assign function, it will get the same value what was modified, like 2 or 3. So guys, this assign function will be called for each vector elements actually in this for loop, and this n is equal to 1 and you are iterating actually, so then it becomes, it's a post incrementation, it becomes to 2, then again for loops next iteration of vector element, again it becomes 2, 3, 4 in this manner guys. So this is in case of C++. So guys, and again you are printing this value guys. So again you are calling for each value, begin and then print function. So this first statement was there to print simple the vector elements, then you have calling the assign function and you are modifying the values, and then you are again printing it guys. So let's see the output in case of C++. So guys, you will get this value was there. In case, since you have not initialized any vector elements, you have simply mentioned the size as 10, but you have not initialized the default value will be 0, therefore you are getting all vector elements as 0. And then guys, when you simply you are modifying it and then you are printing it, since you are incrementing it, you will get this value 1, 2, 3, 4 till 10. So guys, this is how in case of C++. Now let's see how to achieve in C++. 11 the same thing actually. How it becomes easy in case of C++ to achieve the same functionality actually. So this is another snippet of code guys. Same function, same program, similar purpose of the program, but how to use in different manner. So guys, this is again the vector of 10 elements. We are calling for each function. We are passing begin, vector begin, and first argument, second argument. And guys, you can see here, we are not calling any print function. So in earlier case, we was in C++, we are calling print function. So the control goes to the print function. But here, we are not calling print function. We are writing this expression, guys. You can see we are writing this expression. So what is this expression? So guys, I told you in Lambda functions, what happens? You don't require to call the function. You simply can dig the whole code itself. So that is the reason this is a syntax for Lambda function. You need to give the square bracket open and close. So this thing is the input argument actually. So in function, when you give the name, why it is called as anonymous function? Because you don't need to specify the name of the function. So in case of print actually, when you have seen in C++, they are giving the name of the function print and you are giving input argument actually, and then you are writing the block of statements by mentioning curly braces open and then close. Inside that you will write the statements, instructions which you want to execute, right? So guys, here actually Lambda functions, you need to give this syntax, that is square bracket open close, and then you have to give this input argument actually. So you want to pass B actually. So giving input argument, same thing is there, but just a difference is that you are not calling the control, you have not written the different function actually. So this will avoid the control going to that function, and again you are not writing the name of the function, and everything works fine actually. You have written the whole code at that point itself instead of writing different function, different module actually. So guys, same implementation, that is you are printing this value of the vector. So I hope you have seen actually in case of C++, what we was doing is that we was calling calling this print function actually. So this print function was called, control comes here, and we are passing this input argument B, and then we are writing this block actually where curly braces open and then close, inside which we write our statements which we want to execute. So in case of C++ 11, we are not calling this print function. We are simply in that point itself. We will not mention the name of the function. We'll write the syntax by square bracket open close, and then we will write this input argument v actually, and we'll inside the curly braces there itself we write cout. So this is how we are writing in here itself, guys. We are writing this expression lambda function is denoted by this square bracket open close actually, and then we are mentioning this input argument v. Just a second, guys. Input argument v, and then we are mentioning cout. We are displaying the message cout vector elements. So guys, this will be displaying you vector elements, 10 elements actually. And again guys, for assigning actually, again we are calling for each function. We are passing first argument as begin, second as end. Then we are not calling assign function. We are simply writing the lambda function by this by the square bracket open close. We are mentioning the input argument as end, ampersand v, and then this is the implementation, that is static int n is equal to 1. Same code is there, but the syntax is different. We are not calling, we have not written different function, we are not given any different name actually. We are simply dim the implementation of code with input argument and this line itself. So this is called as a lambda function, which is possible, which the C++11 provides you guys. So guys, same thing you are printing again after modifying it by this in this manner, guys. So guys, you will get the output as the same output actually, but by different manner, guys. So this is what about the lambda function. I have covered different programs also. So this is another program, guys. So wherein this is different snippet of code. So I've given many examples to make you clear. So there are one function foo, wherein you are displaying the message simply, and again you are having bar function displaying a simple message. So this is a main function. You know that entry of the program starts from this main function. So when you compile the code, your control comes to main function, and then your instructions will be executed line by line. So you are having this this type of expression. You know what is auto. I've explained you in very first session of the C++11. It's a feature provided by C++11. So if you are mentioning the name of the variable, if you're writing initializing its value, you don't need to specify any data type. If you give auto, compiler will understand by its value what it will be its data type in case of C++11. So guys, for detail you can go through the earlier session which I have covered if you have not gone through it. So guys, this is again a lambda function, square actually open bracket, square bracket open close, and this round bracket, and you are calling these two types. That is, you are calling foo, you are calling var function, and you are writing in this manner, guys. So guys, then you are calling so in this manner, and this is just you have mentioned in this manner, and you are calling this f. So when you call this f, guys, function, then this foo will be called, and then this bar will be called, guys. And guys, again you are using you are creating a vector actually, and you want 3 elements of vector, and you want its value to be printed as 15, 15, 15. So 3 elements is having value 15 actually. You are creating a vector, and then you are calling for each begin, and actually again you are writing. So you're just displaying a message. So these are the outputs, guys, of these things. That is, since you have written auto in this manner, and then you are calling this f function. So this foo will be called, and this bar will be called, guys. So this is how you can achieve actually, you can use your lambda function. This is the way, and this is the way you are printing the message, guys, in this manner. So guys, you will get the output in this manner. That is foo bar 15, 15, guys. So another examples I have covered, guys. So I have covered more examples so that your concept will be clear, guys, for your reference. So guys, again you're having main function, you're displaying, you're having lambda function. When you have square bracket open and close, you understand it's a lambda function. This is the argument which it have, and return a into b, and this 4, 5. So you can use in this manner. So what does it mean? It means, guys, this int a and int b is there, and guys 4, 5 means 4 is passed to a and 5 is passed to b. So guys, it means 4 and 5 is there actually. That is, a will be 4, b will be 5, and then return a into b means 4 into 5, that is 20. So guys, this is different way in which you can use your lambda function. Then again another way is auto f is equal to same thing, but you're writing auto f is equal to in this manner, return a into b, guys. And then you are printing a message by calling f 4, 5. So you are calling this function 4, 5. So you're having auto here. So this 4, 5 will be filled. A will be 4, B will be 5, and written A into B, that is 4 into 5, 26. These are the two different ways actually to get the value, actually multiplication value, that is 20 by 4 into 5. So guys, please make a note of it. So guys, how to return from a lambda function, that also I have written. Actually, this is another different snippet of the code. So guys, you are displaying a message actually, and here you are writing lambda function, you are having n actually, and this is 5. That means n will be initialized with 5, and you are returning n into n, that is 5 into 5, 25 you will get. An explicit return type, this is a different way you can also represent. You can also use this thing in this manner, lambda function, because it's a square bracket open close and int n, and then you can write this arrow key and then integer, this actually 5. So guys, this n will be 5 here, this value 5, n will be 5, and then guys n into, guys this one got shuffled. So guys, this n will be 5 actually, and then this int is there. So return n into n, that will be 5 into 5. So this is the different way which you can represent using lambda function. So guys, all these things I have covered, so that you can use actually depending upon your requirement, guys. So guys, this is all in different manners you can represent lambda function, guys. So guys, I'm done with this features in this part 6. In part 7, I will be covering, guys, enum classes and array container. So guys, please be ready for C++ 11 new feature part 7. So guys, I'm done for now. Thank you guys. Thanks a lot.